Okay, so here we've got a 2 by 2 by 2 cube. It happens to have an octahedron on the side of it, but most 2 by 2 by 2 cubes don't have an octahedron inside of them.
Yep.
Is that true?
Yep.
Are you sure? Okay. Well, this one happens to. So the green's the octahedron, but the blue struts are the...
What we can go on?
Yeah. So I'm curious first, before we do any calculations or any grid counting, how many paths do you think there are going to be?
Well, first, can we go through the inside the cube?
Oh yeah, good point. Good point.
Like,
Yeah, we don't have that point, that middle point inside the cube. You can. We'll have to pretend that point's there. So thanks for pointing that out. I totally forgot about
so
that.
you can, right?
Yeah, you can.
Okay.
That point should be there.
Alright, so that means that there's 6 moves in a path.
Okay.
And you need to choose, so it's going to be 6 choose 2 for the X, and then times 4 choose 2 for the Y, and then the Z will fill in.
All right. So what do you think? What's 6 choose 2?
That's 15.
Do you know what 4 choose 2 is?
6.
Okay, so it's 15 times 6.
90?
90, okay.
Could be 90 ways.
So we have a guess of 90, and let's see if we can do it via grid counting.
Alright.
Do you think we could draw a 2 by 2 cube, or should we just have our 2 by 2
I
cube?
think if we just have this.
Okay, and we can try to remember what the numbers were. There should be some symmetry. Okay.
So we know that there's, if we start at this point and we're going to go over here.
Right, we're going to start at the bottom with the yellow. Snap cube down there just to remind us. That's where we're starting, and the green's going to be up there. Okay.
So we've got one way for all of these 6 points here, and this one too.
So we've got one way to reach them.
Alright, so we have one way at any of the zone balls along the axis.
Yeah.
Okay.
And then, I guess the next step, these 2 and these 3 here are going to have 2 ways.
Okay.
And then, so that means that these 2 have 3 ways. And this one in the middle has 6 ways.
Ooh.
And then,
This one seems to also have 3.
well, to get to it you have to go, the only way you can get to that point is by going along the bottom. Since this point here, no, well, you have to go along the bottom, but I guess the bottom is like a grid.
So you can also go first and go in that direction. You can go in X.
Alright, so maybe on the bottom we can write in 1, 1, 1. How many did you get to there?
2.
2.
2,
And then 1.
1. Can you write over there for me?
There's 1.
And that one would be 3.
3. And then this one here is 3.
Here, I can write it. Alright, and how about it for this corner over here?
It's going to be 6.
6. Okay, so there's our bottom part of the cube. And now maybe, if I slide this over, I still can see what numbers are associated with what position, right? Now maybe we can actually take a look at the 9 points in the middle and come up with what they are. Okay, so this 3 going across here corresponds to these 3 right here.
Alright.
Yep. So that means
So there's 1 here.
1 here.
So it means there's 2 here and 2 here.
2, 2. Okay, so here, this zone ball here can only go up like this, alright?
And then there's 3 here.
Alright.
2 and 1.
Yep.
Okay, so 3.
And then, so there'd be 6 in the middle, like we said.
Okay, why are there 6 in the
Well,
middle?
there's 2 from the bottom
And then 2 from these 2 points.
Oh, nice. And that's the corner of the cube we found last time,
Yeah.
right? Okay. So now what about this ball here?
So that's gonna give us 6 plus the 3 from the bottom, plus this one was 3 as well.
Yep.
It's going to be 12 points.
Okay, 12. All right.
And then that means this one,
That one's
symmetry
gonna
is
have
gonna have 12 as well.
Okay.
And then
And then we've got
that one, this one's going to have 30.
12
20
plus 12
is plus 6.
plus 6, so 30. Wow, so there's 30 ways to get there.
and
Okay.
then I guess this then
So now
if we use this we can make the top
Squeeze this
grid.
over. Yep, I'll make the top grid now. I'm almost out of room, but I think I can squeeze the numbers in. Okay,
So now there's 1 here.
all right.
And from
I guess 1 plus this one is 2, so there's 3 here.
All right, and 3.
And then 5. 3 plus or 6.
6.
That's
So
that's,
one through
that's
six.
3.
So notice that this face here goes 1, 1, 1, 1, 2, 3, 1, 3, 6. Have we seen that before?
So on the top it's the triangular numbers.
Well, but have we seen the numbers on that whole face before?
Well,
1, 1, 1,
Yeah.
1, 2, 3, 1, 3, 6. Where were they?
That's just our 2x2 grid.
Ah, it's just a 2 by 2 grid. All right. All right. So what about the other numbers on this
Well,
top face?
there's a 1, 3, 6 going this way.
Okay, 1, 3, 6. Okay, this way. And
so
now, how about here, this middle point?
that's gonna be 15. Or no, it's gonna be
12. 3, 3, 6.
So the 3 plus 3
3
is 6.
6.
It's 12.
12.
All right.
So this one over here
Yeah, this
is
one
gonna
right here.
be
30 again.
Oh, interesting. Why? Show me where it comes from.
So
comes from
6 plus 12 plus 12.
All right, where's the 6?
So 6 is on this.
All right, where's the 12?
One of them's here, one of them's there.
All right, so that's 30. What's that?
That's also 30.
So now we have
Or this corner here.
30. So we have 30 from this one, 30 from this one, 30 from that one, 90.
90. Hey,
It's
all
like we
right.
found. Yes, we did.
Just like we found. Okay, and because there's a lot of symmetry in this problem, we could go to our choosing numbers
Yeah.
and see. Why don't we pick one of the 30s and see if we can replicate the 30? Let's say this one. So what do I have to do to get to this ball here?
So you're
You have
gonna
to go-
omit a move in this direction.
Okay.
So you have to go 1x, 2y, and then 2z.
All right. 1x, 2y, 2z. So what are my choosing numbers going to be?
So it's 5 choose 2 times 3 choose 2.
5 choose 2 times 3 choose 2. So
So-
5 choose 2 is
10.
10. 3 choose 2 is
3.
3.
So it's 30.
10 times 3 is 30.
Nice.
So there you go. So we've been able to extend our grid counting method to
3 dimensions.
Yeah.
Dimensions.
when there's symmetry, but we also showed you can still use the grid counting method when there's not symmetry. It's just a little more challenging,
Yeah.
but not a lot more challenging, just a little bit. You just have to be careful. But it also showed that it's not quite intuitive when you omit a point. Like the number of paths does change, but it's actually hard to guess ahead of time how it changes. All right, high five, guys. Good work.